Hey guys, it's time for another audio amplifier chip review. Sometimes I get a question from people, what do I recommend for an amplifier? You know, I need something more than an LM386 which puts out less than a watt, but I don't need an amplifier that's 10 plus watts of output. What would I recommend? Well, I have something for you. Let's take a look. Here is the TDA1517, also known as the TPA1517 from Texas Instruments. It's essentially the same thing, same pinout and everything. It works with 12 volts. You can run it in the 10 to 16 volt range. It's stereo, 2 channels, and you can also use it with 4 ohm loads, so you can get a little bit of extra power if you want. It's still available in the easy to use through hole DIP, dual inline package. A lot of these chips have gone obsolete, and this one is still available, but it's from Texas Instruments only. The other companies have discontinued it, but like I say, Texas Instruments still carries it as the TPA1517. It used to be available in this format as well. Has the exact same pinouts on this side. The other side is all ground. It's all used for heatsink. So in this version they just made a heatsink tab. And I'm going to set it up on my breadboard. And because these aren't that good for dissipating power, I'm going to use this one because I can put a heatsink on it. Now if you etch a board with this, you can make an area of copper for heat dissipation, or something you can bolt an actual heatsink to. But again, they're the same amplifier. I'm just going to use this one. Okay, let's take a look at the data sheet. Okay, here is the data sheet. Here's the pinout I was showing you. All this side is for the ground and heat sink. Also comes in a surface mount package if you want to go that direction with it. Here's some data sheet parameters if you want to pause and take a look at that. See here, repetitive peak output current 2.5 amps. That's pretty good. And most of these small little dual inline package chips only go up to 1.5 amps. So this will give you a little extra kick for the using the 4 ohm loads, say at 15 or 16 volts. Now here's a distortion versus frequency graph. And that's pretty good. It's down by 0.1%. It does increase at higher frequencies, and that's with the 4 ohm load, so it's 4 ohms are always going to give you more distortion than 8. But it's still well under 1% even at 20K. Here's for 8 ohms. It's going to be a little better still. Here's the schematic diagram. Now this is what I call a 3rd generation amplifier IC, because it gives you good power output, performance, and doesn't need a lot of parts, as you can see here. Now this is the mute circuit. You don't need any of this if you're not going to use the mute. Just tie the mute to the supply pin. That's all you need. So you just need the output blocking capacitors for the DC, the coupling capacitors, coupling for the input, and there's a power supply bypass and another power supply decoupling, and really that's it. Very easy to use. Well, enough of this. let's hook it up and give a listening test and do the power test and all the other tests that I run. Background squeaks provided by the Snickers. Okay, here it is set up on the breadboard. Ignore these other components. The actual circuit is in this area. And if you remember from the last video with the LM1877, this certainly does have a lot less components. And I did bolt up a random piece of aluminum I found as a heat sink to help keep it cool. And I added this capacitor across the power supply rails because the distance from the power supply here is quite a bit. So that's in addition to the film supply bypass capacitor. It's right there. Okay, have it hooked up to a speaker and music player, and we'll give it a listen. And as I always say, the camera does not convey the sound quality as well as it could if you were listening in person. No issues with the sound quality to my ears. One thing I noticed, when the music's off but the amplifier's on, even if I put my ear close to the speaker, there is no hiss, or maybe just the slightest perceivable hiss. Very, very quiet amplifier, and the reason for that is it's fairly low gain of 20 dB, which makes it not ideal for music players because you have to turn it all the way up, the music player all the way up, to get any output. But it's okay for line level type sources, which the voltage is actually a bit higher than the headphone type output on music players. Okay, well, I'm going to hook up some 4 ohm loads and we'll do some power tests. Okay, we're looking at the spectrum analyzer mode, and we've got to take it out of clipping. Okay, turn that on. You see, when we get into clipping there, it starts to really shoot up in the harmonics. Even though we're not clipping that much, the harmonics shoot off the screen. Let me turn that off, and we'll back that out. Okay, so it's pretty clean. It's very tiny little notches, but it's almost noise floor type, at least as far as this scope can measure. So no real problems there. And I am measuring with a 4 ohm load. What? Quit video bombing me. I'm trying to shoot a video here. Cats, I tell ya. Yeah. 4 ohm loads, both channels driven. Distortion into 4 ohms is going to be a little harder on the amplifier. It's going to be higher, I should say. Okay, now let me hook up my function generator and get a power measurement. See what kind of power this amplifier can put out. Function generator is connected. I have the inputs jumpered together so we're getting signal into both amplifiers on the chip. And both loads are going here, getting a little bit warm. I have adjusted the signal here. See, we can fine tune that. See, it's clipping. Clips on the top first, so you have to tune that out so there's no clipping at all. Let's fine tune that. Okay, looks like 3.41 is jumping around. 3.4 volts RMS. So I use my dollar store calculator, scientific calculator, $1. What do I say? 3.4. I have to square that, then divide that by 4. About 2.9 watts. So that is really pretty good. That is a really good chip to get that amount of clean power into 4 ohm loads, both channels driven. Very good. So that's at a supply voltage of 12 volts. I'm going to adjust the supply voltage higher and see what we get. Well, I went ahead and measured it at several different supply voltages. I'm at 16 volts now, and we're getting 4.31 volts. Okay, so 4.31 squared divided by 4 ohm load, 4.64 watts. Pretty good. And here's the final result. So at 12 volts even, we got 2.89 watts. And at 13.85 volts, that was the max at one channel of the supply that I could get. At 3.9 watts, at 15 volts, 4.2 watts. 16 volts, we got 4.6 watts. I just rounded it down a little bit. Another measurement I made is the quiescent current. That's with the amplifier powered up, but no signal is coming out of it or going into it. So I got 43 milliamps. That's pretty good. You can use this with batteries. It won't be a heavy load, just sitting idle. So there you go, a nice little chip amp. And it's still available today from Texas Instruments in this dual inline package format. Those things are starting to get very rare. And there's the cat video bombing me again. Easy to use, requires minimum components. Very good power output into 4 ohm loads for such a small type package. Of course, you do want to make sure you supply a adequate heatsink. Low noise, low distortion, sounds good to me. Fixed gain. It's just a very good chip amp. The only issue is the gain is kind of low at 20 dB. And like I said before, with these headphone type outputs, not really enough gain to drive it too hard. I mean, you can still use it, it's just that it may not get as loud as you want it to be in certain situations. But then again, it's fine with line level type signals. I have to give this chip a thumbs up. And that's it. Thanks for watching.